Hello everyone, my name is Dan the Tutor. This is a clip from one of my weekly group tutoring sessions at the University of Delaware for Math 221. If you have any questions, please leave them in the comments below. Thank you and enjoy.
We're going to be talking about area between curves today. It's the last topic you learn in calculus, at least for this course. And what we're going to do is it follows a three-step process. I'm going to say step 0 because it's like the first thing you should do if they don't give it to you. Sometimes they do give it to you, but if they don't, you need to draw a graph of what's going on. Draw a graph. If you're not good at drawing graphs, I don't know what to tell you. You need to know just a couple of them. You need to know what x squared looks like. You need to know what x cubed looks like. You need to know what the square root looks like. Let me just write these down real quick. You need to know what y equals x. You need to know what y equals x squared looks like. You need to know what y equals x cubed looks like. You need to know y equals the square root of x. You need to know y equals e to the x. You need to know y equals natural log of x. And by the way, I say you need to know them. You don't need to know them, but they're going to make your life a lot easier when you actually go and do these problems. Now, there's probably like a bunch more that could potentially show up on the quiz or test, but for the most part, this is all you need to know. You can get away with knowing these 6. So then step 1, the real step 1, after you draw the graph, and by the way, this is an optional step. I'll even put this in parentheses. It's optional. You don't have to do it. Step 1, you don't have a choice. You need to do this. You need to find the intersection points. Find the intersection points. What does that mean? We're going to talk about that, but I'm going to put this in parentheses. Set the functions equal to each other. That's how we find intersection points. We're going to set the functions equal to each other. Yes, we're dealing with at least 2 functions whenever it comes to area between curves. And then finally, step 2 is the actual calculus or math part. You're going to solve the following integral. The integral from x1 to x2, which is really just the leftmost point to the rightmost point of the top function minus the bottom function dx. And we're about to look at 6 examples today, or maybe, I'll say 6. I hope we can finish within an hour. I think we will. But any questions so far? Okay, so we're going to follow this 3-step process. 1, draw a graph, which is technically optional, but we're going to do it for most of the problems today. The real step 1, find the intersection points by setting the functions equal to each other. And step 2, find the integral from x1 to x2 of the top minus the bottom dx. This is the most important step number 2, which is why we're going to spend the most time on it. Okay. So now, here's the first problem. Everyone ready? I want to find the area between y equals x squared and y equals x to the 4th. I know I didn't put x to the 4th on there, but you can imagine kind of what it looks like, even if you don't know. So first thing I'm going to do is I'm going to draw a picture. I'll draw y equals x squared in blue, and I'll draw y equals x to the 4th here in red. Now I do need to be careful here how I draw it. It's going to look like this. Pretty much, you can see where it intersects here. And by the way, again, if you didn't know this, it doesn't matter. You can still solve the problem. It's not a big deal. Okay, but I'm actually, if you want to zoom in or whatever, I mean, I can't really zoom in, but I'm going to draw the area here in green. Hopefully you can see that. That's really small. But you see the area. You see the area. And the reason why I like to draw the picture is because it helps me determine which function is the top function and which one's the bottom function. The other reason, this is a particularly devious example because I'm actually going to need 2 integrals here. So step 0 is done. I drew a picture. Step 1, I want to find these intersection points. In this problem, there are 3 intersection points. I'm going to draw them all. There's one here, there's one here, and there's one here. I forgot to label these. The blue is y equals x squared. The red is y equals x to the 4th. Again, if you didn't know that, you don't need to. You can still solve the problem without knowing that. Now, real step 1 is find the intersection points. Again, how do I find intersection points? Set the functions equal to each other. X squared equals x to the 4th. Okay? Now we need to solve this. For those of you who out there who want to cancel out x squared, and then we have x squared on the right, never cancel out x's. If you cancel out x's, you're losing solutions. In this case, you'd be losing the x equals 0 solution. So what do we do instead? I'm going to say this. I'm going to subtract x squared from both sides. So 0 equals x to the 4th minus x squared. Now, this is not an easy function to solve unless you know what to do. And what you do here is you need to factor out the common term. The common term is x squared. If I factor out x squared, what am I left with? I'm left with x squared minus 1. Okay? Now, hopefully, you see what's going on here. I could even factor x squared minus 1. So I have 0 equals x squared times, if I factor x squared minus 1, that becomes x plus 1 and x minus 1. Now I see my three solutions. I have x squared equals 0, x plus 1 equals 0, and x minus 1 equals 0. Which means I get the following three solutions. X equals 0, negative 1, and positive 1. These are the x points of my intersection points. So look at this. Negative 1 right here, 0 right there, and positive 1 right there. Those are my x points. Any questions so far? So now I'm going to set up the integral. The integral, again, there's going to be two integrals here. Why am I setting up two integrals? Well, because there's two green shaded regions. There's two areas. And if I have two areas, which again, this is not normal. This is a particularly hard example that we started off with. And, well, if I knew it was going to be this hard, I wouldn't have started with this one, so I apologize. But it's going to be two integrals. It's going to be integral from negative 1 to 0. Because remember, it's integral from x1 to x2 of top minus bottom, right? So x1 and x2, those are my x points. Negative 1 and 0 for the first one. The top function, just look at the left side. The top function is x squared. So it's x squared minus x to the 4th dx. There's my first integral. Great. Plus, my second integral is going to be the integral from 0 to 1. Those are my second set of x points. And that's going to be the top function. Again, it's x squared minus x to the 4th. That's supposed to be a 4. And then I ran out of room, but put dx there as well. Okay, any questions so far now? Okay, great. So now
actually, I have a question.
Wait.
Sorry.
Yes, let's hear it.
How do you know which function goes first?
Okay, so does it make sense when I'm saying top minus bottom? If not, please tell me.
Are you saying like which one's bigger?
No, I'm saying like I'm looking at this. I can even draw it bigger, like down here. I'm saying if I were to draw this like really, really, really big, I should have color coded it. Hold on. So the blue is this one, and the red is this one. I'm saying which function's on top.
I don't really get what you mean.
Okay, fair enough. So I'm going to draw vertical lines here. Maybe this is a way to see it. It looks like the smiley face with teeth. But if what are my black vertical lines? What's the top touching? What color? What color is the top touching? The black.
The blue?
Yes. What's the bottom touching?
The red?
That's what I mean. Does that make sense?
Yeah.
Now, this is a visual representation. It then begs the question, well, how do we solve this problem if we couldn't draw the graph in the first place? And I was going to talk about that right now, actually. But first, someone else had a question. What was the other person's question?
When you're doing this, are you like reading it from like left to right, like you're starting at negative 1?
I like to. Yeah, I like to, but technically the order doesn't matter.
Okay. And could you just find one side and multiply it by 2 or no?
In this case, since it's symmetrical, yes. But
that's rare, right?
So pretty much, it really depends. It's not rare in the sense that it makes sense because they don't want to screw you over that hard on the quiz. And as I say that, I realize, yeah, they actually do like screwing you over that hard. So if you see it's symmetrical, yes, you can multiply by 2. If you don't know, like maybe it's symmetrical, maybe it's not, don't risk it. You know what I mean?
Yep. All right. Thank you.
Yep. We're going to do this the long way, though. And the other thing I want to mention real quick is what if you couldn't draw this? How do you know which function's on top and which one's on the bottom? Because that's a good question. So we found the intersection points, right? It's 0, negative 1, and positive 1. I'm going to make a number line again real quick. This is not the number line for first derivative test, but it's similar. But what I need to do is I need to figure out which function in not each of these regions, but only the regions between negative 1, 0, and 1, right? Like those are the only points I care about. I want to know which function is bigger, the blue or the red, x squared or x to the fourth. And to do that, I need to plug in a point between -1 and 0 and another point between 0 and 1 into both functions. So that's kind of confusing. Let's do it together. So we have the two functions y equals x squared and y equals x to the fourth. First, I'm going to plug in a point like -1/2 in between -1 and 0. If I plug in -1/2 into both functions, I get y equals -1/2 squared, which is what? +1/4, right? And then the other one's y equals -1/2 raised to the fourth. If you had a calculator, you'd get 1/16 for that. Which is the bigger number, 1/4 or 1/16? It's 1/4, right? It's the bigger fraction. Which means between -1 and 0, y equals x squared is on top. And by process of elimination, y equals x to the fourth is on the bottom because it's smaller. Does that make sense?
So are you doing like the larger function minus the smaller?
I don't like that word, but if that's how it makes sense to you, then yes.
So it's like whatever number you get that's bigger
Yes.
is the function that goes first.
Yes.
Okay.
And then if we did 0 to 1, I mean, you can see it in the picture, and you also know that since it's squared, you're going to get the same results. Y equals x squared, again, that's on top. So that's another way of proving that it should be x squared minus x to the fourth. Okay. So now that we have this, I'm now ready to solve my integral. Since we did a lot of solving integrals before in the last quiz, I'm going to go through this super quick. So it's going to be x squared minus x to the fourth. I'm just going to tell you, x cubed over 3 minus x to the fifth over 5. This is evaluated from 0 up top, -1 on the bottom, plus my integral, plus the quantity x cubed over 3 minus x to the fifth over 5. But this is evaluated from 1 up top and 0 on the bottom. And since personally, I mean, how fast is this to do in my head? Let me just do it real quick. So if I plug in 0, the first term is just 0 minus 0 minus, and again, you have a calculator for this, but -1 cubed is -1/3 minus -1 to the fifth over 5 is -1/5. That would then become positive, plus I plug in 1 here, it's 1/3 minus 1 to the fifth, and then minus 0. So this comes back to the symmetrical thing we were talking about earlier. You're going to get 1/3 minus 1/5 plus 1/3 minus 1/5, which is essentially 2 times the quantity 1/3 minus 1/5. We'll get, if I break this into 15ths to get a common denominator, it would be 5 minus 3 plus 5 minus 3 over 15. Just got a common denominator. And so it's 5 minus 3 is 2, plus 5 minus 3 is 2. 4/15 is our final answer. Again, you have a calculator. I'm not worried about this part for you. But any questions on the process, the drawing the picture, setting up the integral, me plugging in the formula, any questions at all? So if you do have questions and you're afraid to ask, we have, 5 more problems to do tonight? And I was about to say this is the easy one, but no, this was actually the hard one. It only gets better from here. Good news. Actually, I'm looking at my paper one more time. This is the second hardest one. Here's number 2. I have the two functions y equals 1/2 x and y equals the square root of x. And once again, I want to find the area between these two. So again, it's really helpful if you can draw these functions. Luckily, I know what the square root of x looks like. It looks something like that. Let me color code it again. So square root of x looks something like that. Y equals square root of x. And 1/2 x, well, that's just a linear line with a slope of 1/2. So it's going to look something like this. Y equals 1/2 x. Now I can see my intersection points here and here. I don't know exactly what they are yet, but I know I'm looking at this area right here. And just looking at this graph, I know which function's on top. Person who asked the question earlier, do you see which function's on top? I don't mean to call you out. I just want to know if this makes sense.
Is the red one on top?
Yes.
Okay.
And even if you didn't know, again, if you have no idea what's going on at the top and the bottom, you can find out by plugging in the number line, seeing which function is higher in this range. But before we do that, we do need to find out where the functions equal each other. We need to find these intersection points. How do I do that? Again, we're going to set them equal to each other. 1/2 x equals the square root of x. To solve this one, the first step is actually square both sides. It's not fun, but we have to do it. Square both sides. On the left, you get 1/4 x squared. On the right, square root of x squared, you actually just get x. Very cool. Now these x's cancel, right? No, do not cancel out the x's. What happens if you cancel out an x? You lose a solution. Don't cancel out x's. You need to subtract x from both sides. 1/4 x squared minus x equals 0. And again, what did we do last time? We factored out an x. We'll get x times 1/4 x minus 1 equals 0. Now we just need to set both of these individually equal to 0. I'll write up here. So x equals 0 is one solution. 1/4 x minus 1 equals 0 is the other solution. So we need to solve this. 1/4 x equals positive 1. Multiply both sides by 4. You get x equals 4. So we have our two intersection points, x equals 0 and x equals 4. Any questions how I got that? X equals 0 and x equals 4. In case you're wondering, that book of 1001 calculus questions that I got from Barnes & Noble, that costed $22. So not that expensive. Definitely cheaper than your textbooks, but more expensive than anything else you can find online. I actually like the paper stuff, so I got it. I make enough money that I can splurge every once in a while. You know, I was either going to do that or ask for it for Christmas, but I decided to go out and buy it anyway. I have some other textbooks coming in for Christmas. My parents are getting me, I think, biology and chemistry for Christmas. That is sarcasm. Okay, we're going to continue with this problem. So we found the integral, or at least the bounds. We found the bounds of the integral. So this area is going to equal, and I know I didn't put a equals before, but you can if you want, just to remind yourself it's area we're solving for. So we're finding the integral from 0 to 4. Those are our x points that we found by setting the functions equal to each other. The top function is, again, square root of x. I'm going to save myself a step and write x to the 1/2 power, minus the bottom function, which is 1/2 x. Close parenthesis, dx. There we go. Any questions so far? Again, it's integral from x1 to x2 of the top minus the bottom function. Now I just need to solve this integral. Same thing we did before. Integral of x to the 1/2. Hopefully you know this already. It's x to the 3/2 divided by 3/2. So actually I'm going to rewrite that as times 2/3, because again, you can do that. I like to do it right away. I don't even write divided by 3/2 because I know I'm going to change it anyway. And then minus 1/2 times x to the first power will become x squared over 2. There's my integral. I can simplify it if I want, but we are going to evaluate it from positive 4 to 0. So let's plug in 4 first. 2/3 times 4 to the 3/2 power minus this 2 and this 2 I'm going to combine to make 1/4 4 squared. Did I lose anyone? I did 2 steps at once. And then all of this is minus, well, when I plug in 0, I'm just going to give you a spoiler. That's just going to turn into 0. Lucky us. So most of you will need a calculator for this part. However, I did take Algebra 2 in high school. Well, high school. So I don't need a calculator. 2/3, 4 to the 3/2 power is like the square root of 4 cubed. So that's 2 cubed, so 8. Minus 1/4 times 4 squared is 16. So we get 2/3 times 8 will become 16/3 minus 1/4 times 16 is 4. Get a common denominator of 12. You'll get 16, I'm sorry, not 12, 3. But you'll get 12 in the numerator and a 3 in the denominator. We get a final answer of 4/3. Any questions?
Where did you get the 4 from and the 0?
Yes. Yeah, let me scroll up. You're talking about this step here, right?
Yeah.
So I said this 1/2 times x squared over 2 is the same thing as 1/4 x squared.
Okay.
And the minus 0 is because when you plug in 0 into everything here, like 2/3 x to the 3/2 minus 1/4 x squared, you plug in 0 there,
so,
it's all 0. Mm-hmm.
Okay, it's just you plugging in your bounds, basically.
Yes.
Okay.
Don't forget to like and subscribe. If you want me to start doing free weekly group sessions at your university, please post in the comments below or email me at dan@danthetutor.com. Thanks everyone. Bye-bye.